or the sum of the hexagon.
Wait, I think I did it wrong. Wait.
N equals 6 in that problem.
Okay. So then 120.
Yes. All right, very good. Let's I'm gonna just re-grab the shape here. The next part, just be a little, I'm a little unsure how to do the next part for 4 because I can't decide what you're allowed to reasonably assume here. The thing that these like, I'm just going to draw the triangle for a moment because this is related. There is what's called an exterior angle. So if this is 60, then this is 120. That doesn't really help because that's like thinking about extending that line there. I'm not sure how that helps. In the hexagon, kind of the same situation here. We just found that that's 120. So if you extend it, you get 60, but that's like extending either this direction to find this, and that's not going to help either. There's no parallel. I'm a little bit stuck on how to find these. Do you happen to have any sort of solutions to help with
I don't know.
this? Okay. So unfortunately, I don't think I can go beyond 4 and find 5. 5 is kind of the same situation here. There's something about how they meet that I can't quite answer. I mean, this goes in here. So if we find, I'm just going to spend a little bit of time here. So we said that this was for the octagon was 135. So this is 45 here. But then we don't have a way to, we know that, I'm sorry, we do know the whole angle. Okay, actually, I take that back. I guess there is a path here. Let me see if I can do this. So this is 60. And if we extend this line, the whole thing is 120. Not useful though, because we don't know that angle, but if we could find this angle, I guess we can. So this one in here is 135, which makes this 45 when you extend it. And then we know that I'm gonna draw a different color here. We know that this one in red is 120. So I know I've got a lot of lines here, but this 45 and then this one kind of where my cursor is 75. 75 plus 45 gets you to 120. And then you can use that to find angle 4 because 60 plus measure of angle 4 plus the 75 equal 180. They're on a straight line there. It might be easier to see it at 5. It ends up being that 4 is 45.
Okay.
Do you want me to continue with part E to find 5, or do you? And I would reframe this if you wanted us to do that.
Yes, please.
Okay. So we know that this is 135 degrees here. If you draw a line like this, then that angle is 45 degrees, and I'm drawing a straight line there. The whole angle is 120. That comes from the hexagon, which means that the one that's missing kind of right in there, 45 plus that angle equals 120. So X is 75. So once we get that angle at 75, measure of angle 5 plus 75 equals 180. So measure of angle 5 equals 105.
Okay.
So to answer the question about whether a regular pentagon will fit at angle 5, that's the question about 5. You have to do the whole, okay, well, a pentagon is n equals 5. N equals 5 means the sum is 5 minus 2 times 180, which is 540. And then the actual angle measures 540 divided by 5, that's 108. I'm not quite sure how to answer the question. I think one way to look at it is because the angle of 105 for the measure of angle 5, which is 105, is less than this angle, it will fit. It would just be a little gap. Now, if it means perfectly fit, no, it will not. So
Okay.
I'm not sure how to answer that. I apologize. I can't be a little more clear
Okay.
on that, but all right. We move on.
Yes, thank you.
What's the why don't you just give me the next question you want us to work on?
Okay. 23, please.
Okay. Let's snip that in. No picture, no picture. That's always really tough. Find the length of a 45-degree arc of a circle whose radius is 8. So this is the pizza slice,
Mhm.
which is 45 degrees. The measure of the arc is also 45 degrees, but it's better to show it as the central angle. The radius is 8. And so we're trying to find the distance from like A to B.
Okay.
So to do this, if you were to draw the whole circle, you're going all the way around, right? Say it's the circumference, right? Circumference is 2 pi r, but you can break it up with the angle, the central angle out of 360, if you just want the pizza slice.
Okay.
So notice if you go all the way around the circle, it's 360. 360 divided by 360 is 1. It becomes just 2 pi r. So it still works even for a full circle. But your angle in this problem is 45, and this might be something to put on your equation sheet. 45 out of 360 times 2 pi times 8. And you do want to give an exact answer. So you want to leave your pi kind of off to the side for now.
Okay. Is it 2 pi?
It is 2 pi. Yeah. Now there are units, they're just not given. That means it's a walking distance. It might be feet, miles, inches, centimeters, who knows? I guess from what I've heard, your teacher will put units on the test, but maybe not in the homework.
Yeah.
All right. Where should we go from here?
Um. Can we do 26, please?
Given rectangle RECT and circle O. If RT equals 5, that's right there. And P to Q equals 2. Find ET. Okay. All right. So the fact that this is a rectangle is going to be important at some point. The radius of the circle is 7. And you might say, oh, well, that means this is 7 up here, and it is. Totally is. What do you remember about the diagonals of a rectangle?
That they're equal.
They're congruent. And a point from the center of the circle to the radius, to the edge of is called a radius.
Right.
And all radii are congruent. So there's your answer.
Okay. Thank you.
There's no calculation. I know it's like underwhelming. You're like, wait, that's it. Yeah, there's nothing more to do. Why not?
Okay. Thank you. Then can we do 26, please?
Sure. All right, if M is the midpoint of AB, and that suggests we should find M, because why would they tell you something and then you not use it? That's that's a math question, right? We're gonna give you something, we want you to use it. So the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. In words, it's an average. You're taking the average of each. So could you find the midpoint, the average?
Yes. Um, 2 and 4.
2 comma 4, yes. Okay. So in terms of like what that means, it means if you start at the origin and you go right 2 and then up 4, you get to the point M. But what if you take a direct path? What would that give you? What's another name for this kind of this direct path from the origin out to M?
Is it the diagonal?
In terms of the circle.
The radius.
So I want you to find the hypotenuse of the triangle there.
Okay. Is it 2 root 3?
It looks that way because it kind of looks like a 30, 60, 90, but actually the hypotenuse has to be found using Pythagorean theorem.
Okay. Um, 20.
Square root of 20.
Right, sorry.
Yes. And a little bit of a difference, but yes, really important. So now the shaded region, I know we didn't read the problem here, but what's the area of the shaded region? The shaded region is a circle. The area of a circle might be something to write down. Pi r squared is pi square root of 20 squared. This would become just 20 pi.
Okay. Right, thank you.
These questions so far, they're a little bit of misdirection, even if you don't know how to work the problem, try to take a step in the right direction. Like I said, like find the midpoint, or if you know it's a circle, just write down the area of a circle for me. That could help maximize your points towards your final grade.
Right. Okay.
All right, where should we go from here?
Can we do number 30, please?
Yep. Now, do you know what grade you need heading into the final? Like, have you kind of done all the averaging and stuff like that? You know where you're at?
I think we're gonna go over it in class.
Okay. Yeah, it's always good to know, even if you don't want to know, you could try to know that information that way. Maybe it's not as bad as you think.
Okay.
Or maybe it's like, oh, okay, I just have to do this, and I've been getting, I've been getting a B on my, or getting, 80% all my tests. So yeah, I can do that. That's no big deal. But okay. Here is new problem here. It says, so I'm just trying to get this drawing so small. Diagram is marked with PA, P to A, and PD tangent. So the thing to maybe remember here is that tangents are congruent. I don't know if we need that in this problem, but that's what it's asking for. It wants you to find the angle from A to D. All right. And to do that, they give you this other angle, and they give you kind of one that you don't think you need, but it all kind of plays together. How would you find, I'm gonna draw it here in blue. How would you find this one right here? That measure of that angle?
You could do the
Keep it simple. It has to do this 118.
oh 180 minus 118.
Yes. Yes. So that's 62 degrees. Now, sometimes these drawings just have so much going on, and they have stuff that you don't even want to see in them. And so this is 62. This is 26 degrees. This is the one we're trying to find. Why? There is a formula for this, and I guess I'll show it over here. I go like this. I call it X, little m, and big M. X is the average of little m and big M. Add them up and divide by 2.
Okay.
So in this problem, you don't have big M, but you can backward solve for it, if you know what I mean by that.
Wait, the big M is Y.
Yes,
Okay, and the little m is 26.
yes, yes. The reason I use this notation is you also use it in for the external angles.
Is it 49?
It has to be bigger because the average is 62. So it's like 62 equals 26 plus y over 2. And perhaps you just didn't undo the 2 quite right. You multiply both sides by 2 to solve for it.
Oh, no. Wait. Um,
Multiply both sides by 2.
yes. 124 and 52.
When you multiply both sides, you just clear out the bottom. You don't distribute in. So these just cancel.
Right. Okay.
Okay. And then let me just show you this because I think maybe seeing it one time. Let's just say you're like, I don't want to do that. I want to multiply and find 52 plus 2y divided by 2. You then divide both of those by 2. And you get back to 26 plus y. And that's where you say, oh, I didn't need to do that. I could have just like canceled them out.
Right. Right.
Subtract 26. Y is 98 degrees.
Okay. Got it. Thank you.
Right. Okay, to do the next part of the problem, I'm going to grab, well, actually, I need to grab the original picture here. And then we're interested in finding the measure of angle P this time. There's kind of a lot going on here. So with measure of angle P, which is down here, we call it X. There's little m and then big M, but there's also other ways to do it. And let's see here. That's actually not what they're doing here. I apologize. That comes later. So to find this angle here, I believe we can use, well, okay, we found that this is, what did we say, 62 and then 98 here. No, we found that, I'm sorry, we found that this other one was 98. This is 98, sorry about that. 62 is the wrong spot. Oh boy, not good, not good. Okay, let's get rid of those. 62, 62, 118 by vertical angles. One of the things we can do now is we can find the measure of this big arc. It's 360. 360 minus 98. Because the whole circle, if you go all the way around, is 360 degrees.
Right.
Right. So that's how you find this. And you're like, well, why would you want to find that? Get that in just a moment. 260 degrees. And that's what I was trying to draw over here. I didn't want to draw it quite yet now. This works for a tangent, 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 secant, secant, secant. I call this little m. The reason it's little m is because the major arc is big M. And the value for X is big M minus little m divided by 2. This is yet another formula to remember, but you got to get it in context of, what are you doing for that?
Okay.
So you have everything here. Your big M is the 262 degrees.
Mhm.
Your little m is the 98 degree, and x is that external angle.
So 82.
Sounds right. Okay, good job. So there are some formulas here. I guess I should maybe summarize. That's what I was attempting to do here. So there's tangent, which we just saw. There is secant, which we just saw, or which we have not seen. And then there's also like a tangent and a secant. So in all cases, I label x as the exterior angle, little m, big M, little m, big M, little m, big M, and x is always big M minus little m divided by 2.
Okay. Thank you.
No problem. And it's not to be confused with, unfortunately, it's like there's so many of these things. It's not to be confused with, well, what if there's the center and we're looking at a problem like that, where there's x, there's little m, there's big M. Well, this is m plus m divided by 2.
Okay. Got it.
I hate saying that it's a formula, but there's probably a formula for every problem on your final.
Yeah.
So, all right, where should we go from here?
Um. Sorry.
Take your time. It's just
Can we do 32, please?
sure. Yes. Okay. What to do? Okay. The water in a drain pipe is 18 centimeters deep. The width of the surface of the water is 48. Find the radius of the pipe. All right. So if there was a center drawn, that's a little bit high. We draw right there. You could, for example, draw a radius like that, a radius like that. And then there is kind of a other part of this here. And we know that this is 18 and this is 8. I'm sorry, I apologize. That is not what that is. We know that this is a radius, this is a radius, and it's this part that's kind of the small one there is r minus 18. And these are 24, and these are 24. So the 48 is split in half. They're congruent. That's why I can split them up. Radius comes out. The radius also goes all the way to the edge. We know that part of it though is 18. So the other part is whatever the radius is, subtract 18. Is that okay?
Yes.
Okay. I know this is really tough because you have to draw it and like hope that something worked out.
Yeah.
This is a right triangle. And what do you remember about a right triangle? what's kind of the first thing you learn about a right triangle?
The Pythagorean theorem.
Yeah, so that's maybe another thing to put on your note card. You might wonder, well, why would I do that? I don't know the sides. Well, you don't know the sides, but they're all in terms of one letter, which is essentially a special triangle because you can get it from just one set of sides. So we have to square r minus 18 squared plus 24 squared equals r squared.
Okay.
Now, as a reminder, r minus 18 squared means r minus 18 times r minus 18.
So is it r squared plus 324?
You have the FOIL.
Oh, okay. So
You've got two of the terms, but not all of them.
then minus 18r.
Okay,
And
anything else?
Minus
Right,
8.
so yeah, that's the O and the I. So it becomes r squared minus 36r.
Okay, right.
Okay. Any questions on that before we proceed forward?
No.
Okay. So from here, that replaces the r minus 18 squared. So we're going to take those three terms on the right there, r squared minus 36r plus 324. You've got to square 24.
Um, 576.
Okay. Equals r squared. So go ahead and see if you can solve this, please.
Okay. So I added 324 and 576 and I got 900. So then would you subtract r squared minus 36r from both sides to cancel the r squared?
Yes, exactly.
Okay, so then it's negative 36 over 900. Oh, wait, no. 900 over 36.
And see if you can reduce that, please.
25.
It's 25. So r is 25.
Okay.
All right. Can I have just 2 minutes to deal with something? I'll be right back. I'll extend the time if we need, but can I just take 2 minutes here to mute myself and take care of something?
Okay.
I'll be right back.
Right.
All right, sorry about that. There was a person at the door and, okay. Just an Amazon driver.
Oh, okay.
Sometimes they ring the doorbell and sometimes they don't. You're like, why are you ringing the doorbell? You don't really want me to come to the door.
Yeah.
Uh, so, all right. What's next? What can we work on from here?
Um, could we do 33, please?
Yes. Now these problems, we're getting into the B's. They get really, really tired, really, really tiresome. They're difficult. Just keep that in mind here. If there's other concepts, we might want to address, but this one's not too bad. You do need another formula here for this. So let me give you the formulas. There's three cases, but the first one isn't really a case. It's that the tangents are equal. A equals A. That's not really a case, but it kind of starts the process. The next one is if you have a tangent and a secant. When I say secant, I'm meaning you're cutting through the circle, hitting it twice. So what you actually need is the whole part here, the B plus C. And the general form of the formula is part outside of the circle times the whole, meaning the whole length, equals the part outside of the circle times the whole length. So in the tangent side, it ends up being A times A equals B times B plus C.
Okay.
For the other possibility, which is secant, A, B, C, D. This is A plus B. This is C plus D. It's A times A plus B equals C times C plus D. It's still that part times whole, that part outside of the circle times the whole length, part outside the circle times the whole length.
Okay.
So I use these letters. You don't have to use these letters. You just have to remember that's part times whole, part times whole.
Okay, got it.
So, okay, we did all that, right? They're going to give you numbers or letters. Like in your problem, it's X and then 9. But what you really want is the fact that it's X plus 9.
Right.
Actually, let me maybe bring this down just because we're going to run out of room here. We try to solve. So the part is X times the whole X plus 9 equals the part, which is 6 times the whole, which is 6. So when it's tangent like this, part equals the whole. They're the same.
Okay. Okay.
Right. So then we got to multiply in by X squared plus 9X equals 36. Any chance your test is multiple choice?
Um, I don't think so.
So unfortunately, you do have to factor here. You have to find two numbers that multiply to minus 36, but add to positive 9.
Um, 12 and -3.
X plus 12, X minus 3. You have to set each of those equal to 0. Like that.
Right. Then -12 and +3.
Problem is, these are solutions to the quadratic. They're not solutions to your problem. So you have to be very, very careful that you actually solve the problem in question, which is the length of X. X can't be a negative length.
Right.
So the reason this one is not correct is not because it's negative. It's because when you put it back in, you get a negative itself. Generally, one of them will be extraneous.
Right. Okay.
All right, what else you got?
And then 34 too, please.
Which one?
34, please.
34. 34 is impossible. No, it's we'll get it here. All right, first one is to find A to E. All right, so A to E is the vertical here. Wow, they're not giving you much. Oh, it's a parallelogram. Okay. I'm like, now we can do it. That's good. So this right here is 15 minus X because the whole length is 15 because
Right.
it's a parallelogram. The whole length over here on the right is 10, which means that this is 10 minus Y because this part is Y. Okay. And you're like, why would we need all that? Well, if we find Y, why would we want to find Y? I was going to say Y is the easy thing we can find here. AE X goes there. Oh, that's a weird shape. One. Okay, so if we find Y, we can draw this right here. So I'll just shortcut it here because we're running out of time. Y ends up being 1, sorry. So, and you get that from the Pythagorean theorem up here on the right. It's also Pythagorean triple. So when this is 1 right here, you have a 112, and that allows you to find the this other hypotenuse here, square root of 145 from this right triangle here. And then if we call this H, we can say that H squared plus 15 minus X squared equal 10 squared. And then if we do that's the triangle on the left, then the one on the right is X squared plus H squared equals the square root of 145 squared. So this becomes, I'll just keep this H squared plus 15 minus X squared equals 100. We can put the other equation right below it. I'll switch the letters here. H squared plus X squared equals 145. And then you can subtract these equations. So you end up having to span that. So it ends up being 225 minus 30X plus X squared minus X squared equals 100 minus 145. And then those go away. This is minus 45. You move things around, you get 30X on the right, 270 on the left. X ends up equaling 9. Once you get X, you can use that to find H from one of these equations. You end up getting that H is 8 when you're all done.
Okay, thank you.
Yeah, hopefully that somewhat was clear. All right, so we are all done for today.